If pth, qth and sth term of a GP are in GP, terms of a GP are in GP, so these are in GP, prove that P minus Q and Q minus R minus S are also in GP. So let's first take here, let there be an AP as such, and wherein say if there is an AP whose first term is capital A and the common ratios are, then how would you find the pth term? So we know that the pth term will be what? Pth term will be equal to A r to the power p minus 1. Okay. Qth term A r to the power q minus 1. Rth term A capital R small r minus 1, right? Now if these terms are in GP, so when we're in GP we know that, okay, P, Q, R, there's one more term, sorry, that is SF term, S small s, small term is equal to A small s minus 1 here, right? Now, so if these terms are in AP, then what will happen? So how do we find, okay, say if these are in GP, then what will happen? If these are in GP, then the second term upon the first term will give you the common ratio. And what is the second term? So we write here second term, I'll write here A2 simply, upon A1 is equal to A3 upon A2 is equal to A4 upon A3. Now what is A2 in it? A2 you can see is this one, qubit term. So I'll write here A r to the power q minus 1, and here A, the first term is AR P minus 1 is equal to, third term is A r to the term small r minus 1, and it will be A r P minus 1, right? And the last one will be A S1, right? R S minus 1 upon A R P minus 1, right? Okay, sorry, it is just 1 second here. Okay, we have to correct some small error in it. Q minus 1 upon P minus 1, and this will be R minus 1 upon Q minus 1. I wrote P minus 1 here, right? So this is an error here, and we correct it here. So it will be R minus 1 upon Q minus 1 here, and here it will be S minus 1, and this will be R minus 1. Now we got these here. After this, what we have to do is, now we have to say, take it here, like, so we can cross multiply. Okay, why do we need to cross multiply? Let's see. Okay, before we cross multiply, we can cancel something in it. Okay, so what we can cancel here is this one. This will get cancelled, this will get cancelled, this will get cancelled here. So I can write what? I can write here r to the power q minus 1 upon r to the power p minus 1 is equal to r to the power r minus 1 upon r to the power q minus 1 is equal to r to the power s minus 1 upon r to the power r minus 1 here. Now if I cross multiply, take these two at a time and then take these two at a time. So what will happen? This will be r to the power q minus 1. Okay, I can cross multiply, or I can simply be able to take these two together here. See, instead of like say cross multiplication, we can solve it here further. It is q minus 1 and it will be bracket minus p minus 1 using the law of indices. So we can use that. It will be r minus 1 minus q minus 1 and is equal to r s minus 1 and r minus 1 here. Okay, now open the bracket. It will be what? R q minus 1 and minus p plus 1. Here r minus 1 minus q and plus 1, r s minus 1. Okay, it's a minus here. Okay, just to make it, it's a minus here. So s minus 1 minus r plus 1. So everywhere plus 1 will get cancelled here, minus 1, sorry. So you're left with r q minus p is equal to r minus q is equal to r s minus r here. Now we know that if I take these two at a time here, so here if they are equal, the powers must be equal. So which means that q minus p is equal to r minus q here, right? Fine. And if I take these two, then it will form what? R minus q is equal to s minus small r here. Okay, we can have it like that. So if you find, and they are all equal to each other, so I can write it here, q minus p is equal to r minus q is equal to s minus r here, right? So if I write it as such, they are all equal to each other, so we can write it. And once we have written that, then it means what? We can write it as such. There is one more I think we have to write. Here we can write as q minus p upon, if I take these two here, it will be r minus q. So that is equal, if I take these two only, these two, okay, then if these two are equal, then will it not, if I take weight, it will not be equal to 1. If I bring it here down, it will be equal to 1. Same way, if I consider these two, it will give you what? R minus q upon s minus r is equal to 1. So both are equal to 1. If both are equal to 1, so we can further write as here, which means that q minus p upon r minus q is equal to r minus q upon s minus r. Both are equal to 1, so I can write, put them together. Okay, so if I further write, I can write it as such, that is this will multiply here, it will become q minus p times s minus r is equal to r minus q here whole square. So okay, we can say these two are the extreme terms, right? For example, example, if it is A, B and C are in GP, then what happens? B upon A is equal to C upon B. So does it not become B square is into AC? So don't you see it is the same thing here, right? This is the middle term, which is the middle term. This is the middle term here, right? And these two are the extreme terms. This is at the place of A, this is at the place of C, and this is at the place of B here, right? If it is like A, this is C and this is B. So can we not say the these are three terms are in AP? So yes, this is how we can say that they are in AP, and we can say finally that is Q minus P. We can write here Q minus P, right? And the one we had here above, that is R minus Q and S minus R. These three terms are in GP here. Okay, geometric progression, and it is hence proved. Okay, so this is how we have to do it.